Okay, so this is a set of problems dealing mainly with trapezoidal rule, but I threw one in for just a reminder or a related reminder on doing left edge or right edge endpoints for your estimation. The idea is you try these first on your own and then kind of follow through the logic on them and check your answer type of deal. So again, trapezoidal rule, we've already talked about. It's just the left edge and right edge average. So your trapezoidal rule is left plus right divided by 2, which is not really all that complex of a rule. And it does get presented a bit differently in the textbook. However, that's what it boils down to. In this first example, I put 3 multiple choice examples in here. You're looking for a trapezoidal approximation for the area under this particular function. You don't need to know what that function looks like. They're just asking you to chop it up into 3 pieces. And so what we're going to do is we're going to find a right edge and left edge estimate, and then we're going to add those and divide by 2. And we'll get one of these options when we do that. So let's see, we're doing 3 equal subdivisions. That's an important distinction. Equal subdivisions from -4 to 2. So that means we're spanning a gap of 6. So our width of each one is 2. And I'm then going to take and add up my heights. So on the right edge, I've got 3 heights as determined by -2, 0, and 2 as x values. And on the left edge, I've got 3 heights determined by the -4, -2, and 0 as our input values. And I'm putting them into this particular function. So when I do that, I put in a -2. I get e to the negative of a negative, so I get e squared over 2. Put in 0, we get e to the 0, so that's just a 1/2. And then I'm going to put in a 2, and I'm going to get e to the -2 over 2, which is 1 over 2e to the 2. So those are my 3 values plugged into the function, e to the negative x over 2. I'm going to do the same thing with -4, -2, and 0. When I put the -4 in, I get e to the 4th over 2. And I've already got the other 2 in there. So that's e squared over 2. I already plugged -2 in, and that's a 1/2. And then I'm going to add these 2 things together and divide by 2. Now you're welcome to distribute the 2 through. And if you do that on both these, if you distribute the 2, what it's going to do when it hits each one of these is cancel out the bottom, which is kind of a nice feature, cancel out the 2 on the bottom. And that's going to leave us, so that's the 2 being distributed, 2 being distributed. It's going to leave us with e squared plus 1 plus e to the -2, or 1 over e squared. And here it's going to leave us with e to the 4th, e squared, and 1. And then if you add those 2 together, so we'll take our left edge and right edge and add them together, we would have e to the 4th. I have 2 e squareds, I have 2 1s, and I have a single e to the -2, and I'm going to divide that all by 2. And they express that by putting a 1/2 out front. You can see in the options D and C, or D and E rather, they have that half out front, and they're expressing 2e to the 0. They're actually leaving the e to the 0 on here. So we're looking at option E for that one. There's our 4 terms with our 2 being expressed as 2e to the 0. So that's one way the multiple choices have shown it over the years. Another way is to give you a table of values. And in this case, they're giving us a table of values for equal subintervals from 0 to 2. What's the trapezoidal approximation of x dx? So we're going to do our left edge and we're going to do our right edge. So let's see, let's go right edge. We're going with 4 subintervals. So 4 subintervals, these each then would have a width of 0.5. And our left is also going to have a width of 0.5. And we're going to add up our heights. They gave us the heights. We don't have to compute anything. We just need to use the right edges. Those are these. So 3, 5, 8, and 13. And then we need to use the left edges, which are the 3, the 5, and the 8. And we're going to add those up, divide by 2, so that's the same thing we've been doing, but we can do some combining here. So that's 8, 8, so that's 16 plus 13, so we're going to take half of 29. And here we're going to take half of, let's see, that would be 13 plus 6 more of 19. And so we've got 29 halves, and we've got 19 halves. We're adding those up and dividing by 2. Well, 29 and 19 halves, if we add those together, let's see, what would that be? That would be 38, 48 over 2. So 48 over 2 is 24. 24 over 2 would be 12, and we would have our answer at B. So again, right edge, left edge, add them together, divide by 2. And there's our trapezoidal rule. So we're averaging the left and the right. On this last one, this is where they get kind of tricky with it. They're giving you the same kind of subintervals in the table, but they're giving uneven subintervals. So you actually have to pay attention to the width here. It's not the same on each one of them. So we're going from 2 to 8, and they want us to use, they're specifically asking us to use these 3 subintervals. So 2 to 5, well, that's got a width of 3. And 5 to 7, that's got a width of 2, and then 7 to 8 has a width of 1. So we need to incorporate these individual widths times the heights that go with them. And that's going to be, we'll call this one our right edge, and then we'll do a left edge as well. The left edge and right edge always have the same widths. You're just using different heights to determine which goes with it. So if we specifically look at 2 to 5, that's right here. That's our width of 3. That's this first entry that we did, and it's the first entry we did here. If we use the right edge, we're using the 30 as the height. If we do the left edge, we're using the 10 as the height. We'll shift our view over to the 5, 7, 30, and 40. If we go right edge, we've got 40 for our height. If we go left edge, we've got 30 for our height. Shift our view one more time. We've got our 7 to 8. We've got our right edge is 20, and we've got our left edge is 40. And we're going to add those up and simplify them. So let's see, it'd be 90, 80, and 20. So that'd be 190. And then here we'd have 30, 60, and 40. So that would be 130. Left edge plus right edge divided by 2. And what would that be? 200, 320 up top. Divide that by 2, and we're going to get 160, which is right in the middle as answer C. So again, left edge, right edge, divide by 2. This one got a little tricky because they used uneven subintervals, and then you just have to account for the widths separately. Same idea happening on this particular problem for the free response question. So we use a trapezoidal sum given staggered subintervals. So they're not giving you the set subintervals. They're giving us 4 from 2 to 10, and they're asking us just to approximate the average height of the tree. So in order to do that, we're just going to say, okay, well, we'll go from 2 to 3. That's going to have a width of 1. And then our height is going to vary depending on if we're looking at a right edge or left edge. But we've got a width of 1. Then we're going to have from 3 to 5 a width of 2. And then from 5 to 7, we're going to have another width of 2. And then from 7 to 10, we've got a width of 3. So we have to account for the different widths. And then we just have to go through just like we just did and pick out the heights. So we're going left edge, right edge. So right edge is the 2. And if I just look at this spot from 2 to 3, again, width of 1. The right edge, we've got this 2. And then the left edge, we've got the 1.5. So there's our right edge, there's our left edge. Shift over 1, we've got right edge of 6, left edge of 2. Shift over 1, we've got right edge of 11, left edge of 6. Shift over 1, we've got the 15 and the 11. Same process, let's add these up. We have 2, 12, 22, and 45. And when you add all those together, is that going to be a 30, 75, 81? And then we do the same thing with the left edge, and they got tricky. They gave us a decimal, so let's do the other ones first. Let's see, 1.5, we've got a 4, a 12, and a 33. So let's see, the 33 and the 12 would be a 45. There's a 49. There's a 50.5. When we put those together, we take our left edge, take our right edge, add them together, divide by 2, and that's going to give us a trapezoidal sum. So let's see, that would be, what, 131.5 divided by 2. This is free response. That's an equivalent expression to anything they might have written in an answer guide, so you're good to go. If that leaves you uneasy and you want to write it in some other format, you are certainly welcome to do so, but you do not have to. So this would be our trapezoidal sum approximate, and I'm just looking at it, seeing if it's worth it. It would be, what, a 65.75 if we decimaled it out. I think I got that right. That 60 would be 120. There's 130. There's our 1.5. So if you wanted to feel good about getting it in a decimal version, you could. But they're equivalent and they'd be equal. The last one that we'll look at is not trapezoidal. It's Riemann Sum Example. And I put a little note in here. This one's giving you a table, just like the other one did, but then it's giving you a little more information. And it's a bigger problem, but this is just the little piece of it that's dealing with the Riemann sum. The justification piece attached to this. So they've got to give a reason for your answer. They might do that sometimes specifically with left or right Riemann sums. And this is just a reminder, so here's a reminder, that for an increasing function, right edge gives an overestimate, left edge gives an underestimate. So think parabola going up this way. If I were to do a couple subintervals, if I do a right edge, I've got all these overhangs. So I've got an overestimate, because when the function's increasing, going up, your right edge is always going to leave you overhangs. Your left edge then consequently would give you an underestimate. And it flips when you have a decreasing function. So if you have a decreasing function, something going downward, the right edge then gives an under, and the left edge gives an over. For the reason for your answer, that is all you need to state, is do you have an overestimate or an underestimate based on increasing or decreasing, which in most cases means you have to take a derivative. So they're specifically asking you to take a derivative of this thing. And I can see, just looking at that when we take a derivative, we're going to get something negative when we multiply by the derivative of the inside, and our input value it's going to mean we have a decreasing function. And so we'll tie that into our answer. So if we want a left Riemann sum, just a left, not a trapezoidal, and we want to do 4 subintervals. So left edge, 4 subintervals. First subinterval has a width of 1. Second has a width of 2. Third one has a width of 3. And the last one has a width of 2. And that's just looking at the gap between these two values, these two values, these two values, and these two values. I'm then using lefts, so I'm going 1340. I'm going, what would I go? 1190, 950, and 740. This is a calculator question, so fear not on this. You can punch this into a calculator, which I'm going to let you do on your own, and you can certainly verify the estimate answer. But you would just punch this in, and you would get an estimate. You're then asked to say if it's an over or under for the actual expression, so then we need to take a derivative. So W prime, let's see, whenever you have e to anything, it's e to that thing times the derivative of the inside. Well, the derivative of the inside is this guy. So that would be negative 2t over 20. That's the derivative of the inside. That's using the chain rule. This piece of it is always positive. This piece of it is going to be negative when t is greater than 0. So when t is bigger than 0, which it is for this entire table, our derivative is negative. Therefore, we have a decreasing function on this interval. So decreasing on the 1 to 8, or 0 to 8, I guess, interval. So you'd say, so if we're decreasing and we've got a left edge estimate, it would be an overestimate. And there, the thought process is if we have something that's decreasing, so something like an upside down parabola, and we're using left edges to do our approximation. Let's say we go from here to here. If we're using the left edge on this thing, there's our left edge. And let's see, our left edge would be here. So we would get an overhang on this, and we would say it's an overestimate because it's decreasing. They don't need to see you draw a picture. That's just to help visualize it. They just need to see that you can say it's decreasing. So again, I just threw this in here because it's related. You certainly, this is just related to trapezoidal. It's not itself a trapezoidal question, but it's good AP review. So hopefully it helps. And if you want to see the answer on this one, again, you can punch, or get a specific answer, you can punch this into a TI.